Okay, well, let's go ahead and get started, everyone. It's a little after 2 o'clock on my watch. So thank you all for attending. Again, I appreciate it. My name is Jeffrey Gillen. I'm an educator in data science at the Data Science Institute here at the University of Arizona, and you have tuned into NextGen Geospatial. So it's my weekly geospatial data science series where we try to do something new, something a little more cutting edge, and most of what I do is kind of open source tools that people can use. So we'll just go ahead and get right into it. So this week we're going to shift away from the deep learning, which we did the last couple of weeks, and we're going to focus on something called cloud native. And so today we're going to focus on a specific format of cloud native format called cloud optimized Geotiffs. So I'll just go ahead and get into my course content here. Okay, and so here is the course website that we have been using every week. It is on GitHub. Michele, could you post that in the chat if you're able to? So you guys are able to follow along if you would like, or find this material asynchronously. So it's written in a way where you can just step your way through it without my guidance. Hopefully you guys are able to do that. So here's the course material. Let's go down to the schedule. Right, so the last 2 weeks we've looked at 2 different Python libraries for deep learning. So we're going to move on from that and do cloud optimized Geotiffs. So let's go ahead and click into the content for today. All right, how's it looking? Able to see my screen? How's the text size? Look okay? All right. So as I go through the material, I would focus mostly on what I'm saying. So focus on my voice, look at the pictures, and if there's any like text, that I would like you to really look at, I will highlight it. But please don't try to read the text as I'm scrolling through the content. If you're interested in learning more and actually reading the paragraphs, feel free to do that on your own time asynchronously. So cloud optimized Geotiffs. Oh, did that just put it in chat? Okay, great. Thank you, Michele. And Michele put the course website in chat if you're interested in following along. So cloud optimized Geotiffs. Many of you have probably already heard of a Geotiff. It is a typical raster file format, a grid. It's a file format we use for all types of geospatial or remotely sensed imagery. It's probably the most common format out there for satellite imagery or drone imagery or aerial photography imagery. So what a cloud optimized Geotiff is, it's taking our classic Geotiff, and we are rearranging the creation of it a little bit, the organization of it a little bit, to make it more optimized, I guess is the word they use, for work directly on the internet. So we're going to do 2 cloud native sessions, one today and one next week. And the idea is that as our geospatial data grows and proliferates, and there's just so much geospatial data out there, I bet many of you are creating your own geospatial data. I have generated terabytes of data from drones and from analysis of aerial photography. It's quite heavy and large to share that imagery with other people. And so the idea with cloud native is that we can, instead of using the download model, which has been kind of the paradigm that we've used for 25 years or something, we can skip that and go to the streaming model. And the analogy I like to use is around the streaming of other media in our lives. How often do we download movies anymore? Probably not so much, because we're always on Netflix or Amazon streaming movies. How much music do we download? Well, that might be different. I bet we are still downloading music to our phones, but still a lot of our media is streamed, because we don't really need to own it necessarily or have it in our possession. We can just grab onto it or tap into it from a remote source in the cloud. And so we can do the same thing with geographic data, geospatial data. In this case, Geotiffs. The image you're looking at here is a cloud optimized Geotiff, or a COG, of some drone imagery here in Tucson. And we're actually going to look at it in a more interactive way a little bit later. But yeah, so we're talking about COGs. COGs is a file format just like a Geotiff, but organized in a way that makes it more useful for streaming across HTTP. And so the modes of getting data through HTTP, we talked about the traditional download model. That's kind of status quo. It's what we're still, for the most part, doing. But I want to talk about file streaming. And so a COG is organized or created in a way that allows you to stream parts of it from cloud storage somewhere to anywhere else in the world, into an application, into a website, into a Jupyter notebook, into somewhere where you can do analysis. And so think about a giant satellite scene. Maybe this satellite scene is, maybe it's a 20 gigabyte scene or something, a really large satellite scene. Probably you don't need that whole scene. Maybe you're just interested in like a little area of interest. And if that satellite scene were sitting on a cloud server somewhere, you could literally just kind of request just that little bit. And so you could create a little window and pull that window to you to do analysis without having to download the entire file. And so that's what cloud native and cloud optimized is all about. It's about making it a little easier and a little more efficient, more streamlined to move large files. So we don't need the whole giant file. If I just have an area of interest, I can just stream that little thing over to me. And so that's what we're actually going to do in a little bit. So before we get to the hands-on, let's talk about a little bit more theory. So I have a little blurb here about TIFFs. They are tagged image file formats. TIFFs have been around for a long time, apparently 1992. They are very, very common for geospatial, Geotiff. So it's a TIFF, but it has geographic coordinates specifying where on the Earth this image is at, what its coordinates are, what its projection is, things like that. And so it allows us to view and analyze it in a GIS, in an environment that is coordinated. So that's what we're building on top of, is a Geotiff. So a cloud optimized Geotiff, or a COG, is basically, it's a Geotiff, but we've added some things to it. Specifically, we have added tiling, so internal tiling, and also overviews. We have written that and baked that directly into the file format itself. So some of you might be thinking of tiles and tile servers or other kind of map servers. And so, yes, that is typically what we would do in the past. You would have, let's say, a raster of some kind, and then through a tile server, you could, send it out to someone on a website. And it makes it more efficient because you're sending the information over in little tiles. And a tile is, you're taking your big image and you're breaking it up into smaller squares, essentially, smaller little quadrants. And that makes it easier to send across the web and for display. And so with a COG, we are doing that, but we are doing it internally. So it's actually baked in to the file format itself. And so tiling is a big part of COGs, and also overviews. And so overviews are the downsampled images that we have when you zoom in or out of a image in a GIS, for instance.
What is a raster?
What is a raster? A raster is probably one of the three main file formats in GIS or geospatial. So raster is a grid. This thing here is a raster. Think of a raster as an image file. A raster is just another name for an image file. The other types I want to mention is vector, which are points, lines, and polygons. And then I guess the third might be point clouds. And then a fourth could be like a data cube, maybe. I don't know. Depends on how you want to lump or split. But anyway, so we talked about tiles. And so yeah, overviews are also baked in. And so if you ever like put data into ArcGIS, for instance, it asks you if you want to build pyramids for faster display. So that's what this is, only we are writing it directly into the file format. And so it makes it quicker when you're zooming in and out to, to display and look at your image. So tiles and overviews. And then finally, to make this happen in a streaming way, there's something called get range request, also known as byte serving. And so this is the same technology behind streaming audio and streaming video. You don't have to have the entire file to look at it, to interact with it. You can get pieces of it. And so we are streaming geographic data from cloud storage out to an application or a website or an analysis environment, something like that. All right, let's look at some examples, like who is using COGs. COG is probably the cloud optimized format that is gaining the most momentum. Microsoft Planetary Computer, their entire data catalog is written as COGs. What else? European Space Agency has a lot of Sentinel-2 stuff in COGs, and that is in AWS. And so when we say COG, it typically needs to be in an HTTP server, i.e. like a cloud server. And so the data is hot and ready to go. In other words, someone can just tap into it with the URL, pull the whole thing or pull a little bit of it, over to you to do stuff with it. Planet, the satellite imagery company, is big in this kind of cloud native ecosystem. I think you can stream out all of their imagery as COGs. And we can show a few examples here. Okay, so what you're looking at is a cloud optimized geotiff or a COG of some drone imagery I took along Santa Cruz River in Tucson. And so, yeah, it just looks like a geotiff, right? But the way that it's being displayed in terms of tiling and overviews is already baked into the file. And so there is not a file server behind the serving of this. It's on a website called Data to Science that my colleagues at Purdue University created. By the way, it's a really great platform. I should do like an entire session on Data to Science. It's a really very interesting platform for visualizing and sharing geospatial data. It's targeted more to drone data, but I think really could be used for anything. So if you zoom in, let's see if it resolves itself better. Yep, so there you can see the tiling at work here. Starts out a little blurry, and then, square by square, it kind of comes back into focus. So that is the tiles and the overviews that are being read directly from the file. All right, let's try another example here. Okay, yeah, that's what I was showing before. And so it could be any type of geotiff. So this is a classification, like vegetation classification of the same area along the Santa Cruz River. This is also a COG. And chances are you might not know it is a COG. If you're viewing it or using it or whatnot, it's just going to act and look and feel like a geotiff. But behind the scenes, the file format is a little different. So yeah, this is just another example of a COG displayed on a website called Data to Science. Anything interesting in the chat?
Yes.
Were there tile limits because of the altitude you took the drone? Let me see here. Hi, Dan. Were the tile limits because of the altitude you took the drone imagery? If you zoom in, you lose the tiles? I don't think so. I think it just wasn't displaying as quick as it as you want it to sometimes. But yeah, I don't think there's any kind of scale limitation on what's displayed or not. You might be able to set that when you create your COGs, but typically I've not seen that. Okay, Keep going down. So applications that can use COGs. So COGs, or cloud optimized geotiffs, are geotiffs. So they're backwards compatible with any software or any program that can read a geotiff. That includes ArcGIS, QGIS, Google Earth Engine, anything. So it's not like we have to write all new software to read this file format. It's the same file format. It's just been organized in a way that makes it more efficient across HTTP. Hi, Randall. Is the tile concept the same concept that is used in astronomy? I know, yeah, Michele's saying yes. I know nothing about astronomy. Okay, so yeah, you can import and export COGs in and out of Google Earth Engine if you're interested in doing that. How do you create a COG? Thankfully, this ecosystem is growing. So I just learned that ArcGIS Pro 3.3 can write out COGs. So if you're using the Esri ecosystem, you can create a COG very easily. Before that, I would typically use GDAL, which is a command line tool, and I have a little tutorial on how to use GDAL to make a COG. There is another program called Cogger. I believe in the Python library raster.io. There's a way to do that also. So there are a handful of ways to make COGs. And of course you can stream COGs right out of the Cyberse data store. We've got to plug our in-house products. And so yeah, the idea is that the COGs are sitting in cloud storage somewhere in the world, and it can just be with this cloud optimized format can more easily be streamed across the internet for people that have interest in using it. And so before we get to the Jupyter Notebook, so we are going to do a little bit of Python in a Jupyter Notebook to show you some kind of basics of how it works. Before we do that, let me talk a little bit about tile servers. For instance, if you have a COG, do I still need a tile server? The answer is it depends. So if you're an individual researcher and you are generating COGs and want to just share them with the world, no, you do not need a tile server. And it will still work. If you are like an institutional data provider to people and you have hundreds or thousands of people coming to your website to get the data, yes, it would probably help if you had a tile server on top of it, or below it, or beneath it, or however you want to say that. And there is a tile server specifically made for it. A tile server is called T-Tiler, and it's specifically made for this cloud native ecosystem. And then I have another question. How are COGs different from XYZ tiles or web mapping tile servers? Because yeah, when I first started looking at COGs, I'm like, yeah, how is that different than a web mapping service or a web tile? Okay, the difference is the typical web mapping tile service or web mapping service or XYZ tiles, that is primarily about efficient display. So that data is being served to someone's internet browser on their laptop or something, and it's all about just what it looks like. Like Google Maps is a web mapping tile service, I believe. It's mostly about display. COGs are about the actual data. You're actually sending the data to someone and they can take it and then cut out a little piece of it or whatever. So it's more about sending the data as opposed to just showing someone the data for visualization's sake. Can you ask your question in a different way? Yeah, it's about your user looking at it, just looking at it. Like, think of Google Maps. But a COG is like, I'm actually giving you the data, and now you have it and you can analyze it and you can do something with it. You can take it and have it. Yeah. Okay, so that's just what I want to say about that. And then let's get into
There's
All
a
right,
comment.
Jupyter Notebook. Yeah, is there a comment?
Dan says, I'm excited to see what you can export to COG with the GEE JavaScript API. That's great to know.
Okay, yeah, Dan, we can chat about that after the notebook. But yeah, that's interesting. Dan is talking about Google Earth Engine and how to use that with the JavaScript API. Okay, interesting. Okay, so yeah, let's jump into our Jupyter Notebook. I'll just click this button here, open in Colab. Okay, so again, if this is new to you, what are we doing? We are running Python code, and what you're looking at is a Jupyter Notebook. A Jupyter Notebook is a place to run Python code in your web browser, and it's being hosted on Google's cloud computer, and it's called Colab. So Google calls it Colab. So it's just a place that Google allows us to host our Jupyter Notebooks to run code. And so Colab is a product from Google. And so they give you a free tier to play around with. It's great for teaching. It's great for initial exploration of code. But if you're doing anything real and you like real projects, you're either going to have to pay Google for a larger tier of computation or use something in academia like Cyverse or Jetstream 2 or some other kind of could just be your own local computer. But yeah, Colab is great for teaching. So that's essentially why I use it. And Colab is great. It's a one click and you're in kind of thing. Everyone has a Google account already. So it makes it nice and simple. So I'm just, first thing I can do is I'm going to connect to my resources here. And so I'm going to get a little bit of CPU. I do not need GPU in this case. The previous two sessions we did use a GPU because we were doing deep learning. In this case, we're not. Yep, Dan, we do not need GPUs in Colab this week. Yeah, this is going to be a lot less computationally heavy. All right, so what we're going to do in this notebook, again, if the Python is new to you, please do not focus on the exact syntax or the exact lines of code. I'm just going to go through it and click it. And if you're following along, you can do the exact same thing. You can just click run. And if you have deeper questions into like, what is that code doing or how is it working? That's something we could talk about offline or another time. But for today, it's mostly the big picture of what we are doing. Okay, so this Python notebook demonstrates the use of a COG. It will show you how to stream a COG from cloud storage into this Jupyter notebook, and then how to make a subset of that COG and analyze it without having to download the whole darn thing. All right, first thing we need to do is install a few packages here. So I'm just going to hit run, which is the play button, and I'm going to run the Python code. So hopefully it works for everyone as well. So I'm installing raster.io, which is a very useful Python library that deals in rasters in the Python ecosystem. Okay, now that I've done that, I'm going to bring in some libraries. Some are from raster.io, some are from matplotlib, numpy, requests. So kind of typical stuff. All right, next we are going to actually declare where this COG is. So I have a COG, a cloud optimized geotiff from Planet Satellite Imagery. And this was acquired in September of 2020, and it's of Mount Lemmon, so right outside of Tucson. So back in 2020, I was doing a analysis of before and after the Bighorn fire that burned up in the Catalina Mountains outside Tucson. And so that's where I originally got this data. And so we're going to use that as our test data set. So it is a big raster COG, satellite imagery. Okay, next is without actually bringing it to us. So we have not done it yet. We just declared what the URL is, but we haven't actually brought it over to us. So before we do that, we can actually get information about the COG. We can reach into that URL and pull out some information about what the data set is. So this is some metadata that's attached to that data set. We know it's a geotiff, it's a gtiff. Unsigned integer 16, so that's its bit depth. We know its height and width in terms of pixels. What else? Tiled equals true. That might be important. What else? The coordinate system, which is this. I don't know what the coordinates. It might be a UTM coordinate system. Does anyone have EPSG codes memorized? 32,612. I think it might be UTM, Universal Transverse Mercator Coordinate System. What is it?
Zone 12.
Zone 12. Yeah, so it is UTM Zone 12. Thank you. Okay, so we learned a little bit about it. So maybe you can do that command to see if you actually want it or not. Do I really want that? Okay, I think we do. What else? I can do this code block to figure out how big it is. All right, and I got this output here. 2 billion bytes, 2.19, which is 2.19 gigabytes. Yeah, so 2.19 gigabytes. So it's a fairly large file, right? It's a satellite imagery geotiff, and it's a little big, a little over 2 gig. Yeah, 2 gigs. And then I can run this little code here to ask it a couple questions. Is it a COG? And what does it take to be a COG? It has to have the tiles and the overviews baked into the geotiff. So I can run this, and yes, it did find overviews, it did find tiles, and so true and true. So most likely this is what we were dealing with here is a COG. Okie dokie. So rest of this lab is going to be showing you kind of 3 different ways to bring in data. I'm going to do this as a comparison. So the first way is to just download the data to disk. So that's what this code does. It's going to take that URL, go get the COG, and actually download it to our virtual space here in Colab. I'm just doing it to show you the different ways to get in data. You know, so this is the typical way, the download model. So the data is in cloud storage. I'm going to download all 2.19 gigabytes, and it should then appear here in my Colab storage. And it's taking a little bit. I should have written in like a progress bar. Yay, COG downloaded successfully. I love putting these little like statements, you know, at the end that tell you if like you did good, like it worked. That always makes me feel good. So I like putting in these like printed statements like, yeah, COG download successful or failed to download. Because sometimes when you run a block of code and it failed, you're like, I mean, I don't really know what happened. But if you get like an explicit message, I feel better. Okay, so here is our COG example. Here's the COG I just downloaded. Yep, a little over 2 gigabytes. It's sitting there in cloud storage. One thing to know about Colab is I believe this cloud storage will vanish, will disappear once you disconnect. I don't know if it's like I think they probably have it on a timer, but it's just something to know in general with Google Colab. Your data in your storage here is not permanent. It will just go poof and disappear. So Colab is a place where you work temporarily and then move your data or whatever you're working on off, move it to your local machine or somewhere else. Okay, so then let's try method number 2. So instead of downloading it and then bringing it in, we can read the entire COG into memory and then interact with it that way. So I want to be looking at the RAM here as I'm doing this as kind of a resource use inquiry. So when I hit this code block, it's going to bring the entire COG, all 2 gigabytes over to me, but it's going to be in memory. It will not be downloaded, it'll be in memory. So I'll just hit play here. And I just kind of wanted to watch this this RAM resource and see if it spikes. Yep, it's going up a little bit. We'll see how long it takes. Yeah, I'm at 5.2. Yeah, so it's starting to use up our memory, and with Colab, we don't have a lot. Dan is asking, is the image north up? Yeah. Up on the planet satellite images is north. Up is north.
I have a question. If it's north up, what happens when you are in the southern hemisphere and you take images in the southern hemisphere? You
I'm not quite sure I understand, Kaylee.
Sorry, I'm gonna ask this question later
Okay.
because there's only one.
Okay, so we brought that COG into memory. As you can see, it did spike my RAM a little bit. It didn't crash my session, but it did, bring in, did use about 2.5 gigabytes of memory. Okay. Yeah, I'm just trying to show you that there's a lot less resource use when you bring a little bit of a COG instead of the entire COG. So that's the entire COG. And here's display. It's I really need to work on the color guns here. So this is, what is this showing? Is it showing one band? I think it's just showing one band, but like in a blue color. Anyway, so this is a satellite image of the Catalina Mountains and a little bit of Tucson. Yeah, next time I need to get better with the visual. Okay, so this next code block will do what COGs are kind of meant to do. And so instead of bringing in the entire 2 gigabyte file, I can just bring in a piece of it, a subset. So this code block is going to make a subset, like a rectangular window. That's what we're doing right here. We are defining a lower left corner and upper right corner. So we're making a rectangle, right? And I'm saying use that rectangle to go and get the data from cloud storage, and just give me that. Don't bring in the whole 2 gigabyte satellite image, just bring in this subset. So actually, I would like to restart my session. Okay, restart session. So I'm restarting it just so like my resources are back to kind of zero. And I just want to see what it looks like when I just do that instead of downloading, instead of bringing the whole thing into memory. So I'm just going to run through this real quick. Yeah, UTM, which is like latitude and longitude. Yeah, same idea. It's just a different coordinate system, universal transverse Mercator. But yeah, it's a geographic coordinate. So well, it's a projected coordinate system that is using north and easting and northing as ways to tell you where on Earth it is. Okay, just gonna click through this stuff here. Is it a COG? It's still a COG. All right, we'll get to what I want to do here. All right, so I'll click play on here. And let's look at our resources as I do it. And so yeah, this is going to bring in just a subset, just like a little window of that cloud optimized geotiff. Okay, and so it's showing it right there. And so that was really quick, right? That took hardly any time. You look at my resources, it didn't even hardly touch the RAM. I have I have nothing on disk. And so it's just a much more like efficient kind of streamlined way to bring data into your environment. So this subset here is right over Summer Haven, so right at the top of Mount Lemmon. So yeah, it's just a much smaller little area, and I can just bring that in because it's a cog. And if I click this, I think it's just going to display it in like true color better. Yep. So that is, yeah, still didn't look great. But this is 3-meter satellite imagery, so it's not super high res. Anyway, this is Summer Haven. So here's a little subset. And then I could calculate an NDVI. So let's do that. So this satellite imagery is 4-band, I believe. So red, green, blue, near infrared. And so with NDVI, most of you probably know it's a ratio between red and near infrared. And NDVI is very useful for looking at the health or the greenness of vegetation. Green plants are going to reflect a lot of near infrared light, and they're going to absorb a lot of red light. And so the ratio between red and near infrared is a great way to look at how green or how healthy vegetation might be. And I'll just go ahead and click play. It's going to calculate an NDVI and then show it. Okay, so that's what we're looking at right here. So it just did that on the fly. The greener areas are probably going to have more vegetation, so it's probably has more pine and fir trees. And then towards the red or the yellow are going to be the areas that probably don't have a lot of vegetation. These red areas over here were burned in the fire, and so that's why it's not green over on this slope here. Summer Haven in the middle here was mostly saved by the Bighorn fire. The firefighters did a great job of protecting Summer Haven because that's where all the properties are at. Okay, we got a question. Okay, Dan, I assume the red blotches in the center are the built environment. Yes, it is. I'm trying to imagine what those that might just be a cleared area or something that is that's not indicative of fire in the middle. It just means there's no vegetation there. So maybe it's just like a dirt lot or something. I'm not sure. Okay, Matthew's asking, can COGs be used in R? I guess the answer is I don't officially know. I assume so. I would look at Matt, I would look at your R packages and see what's available. I would be surprised if no. Like I would be very shocked if you couldn't work with COGs in R. I mean, of course you can, it's a Geotiff. Like it is a Geotiff, so anything backwards compatible, it should work. But can you bring in like a little subset into R? Probably. I have not actually explored what R packages or code would do that, but I assume so. So I think it's be something great for you to explore and report back to me. Okay, so almost done with the notebook here. And the last thing we can do is we can take our subset, like our little NDVI, and we can then save it out. We can get it out of here. So I just click this button. So it says NDVI image saved as NDVI image.tiff. Excellent. So that should pop up like right here in my cloud storage, and then I can just download it to my local machine. And so, yeah, I guess the kind of the take home is that you can bring in pieces of data, not necessarily have to do this download model of bringing or of storing gigabytes and gigabytes of satellite imagery on your desktop. One thing to keep in mind though is that COGs and cloud optimized technology is still like a new kind of cutting edge thing, and COGs have really been adopted, and ever more so. The fact that ArcGIS Pro can output COGs tells you something. But I think a lot of the institutional data providers, I don't think have really gotten on to using COGs yet. So don't think you can go to all your favorite USGS or NASA sources and get COGs for all your data sets. I don't think that's quite possible, but I know this technology is really penetrating a lot of institutional players in academia and private companies. Anyone that's doing geospatial, COGs are going to happen. I'm pretty sure. They might just not be available for you right now. So I think of this as more like a long game, and also a way for you to share out your data. I'm very much a proponent of open science, and I, as a geospatial person, I generate a lot of things, and a lot of those things can be put in cloud storage and can be streamed out to anyone that is interested in using it. And so, let's say you're in your Python environment here. Just here, instead of downloading, let's say you have imagery sources from 5 different places. You could bring in just like a subset of 5 different imagery sets from 5 different places all into your little Jupyter notebook without having to download a whole bunch of satellite imagery. And so that's kind of the vision of this cloud optimized stuff, is that it doesn't matter where in the world you are, you can get a little piece of data for whatever you're working on and not have to replicate, or like duplicate large files on everyone's local machines. Okay, Dan in the chat mentioned there's an R library in GitHub, excellent, called RCOGs. And Derek says, can you specify the subset using a geospatial polygon, or do you have to compute the window corners manually first? I don't know the answer to that, Derek. I would assume yes. When anyone asks me, can you do this in code? I just say yes, because that's usually the answer. I don't personally know how, but I'm sure you could give it like a maybe a GeoJSON or some other kind of polygon that I bet would work. Yep. And Dan, thank you for providing the color commentary, Dan. Yeah, it does look like NOAA is starting to provide some data as COGs. Excellent.
NASA does too.
What is that?
NASA.
NASA. Yep.
Server.
Okay.
And with Amazon.
Okay. Is that part of AWS's like open data program? I think they have like, yeah, something called open where they have just like a bunch of.
I think they have their own server. It's called Earth Data.
Earth Data?
Okay.
Okay.
But the activity is from the AWS. So that's where NASA is.
Yeah. Okay. Yeah. So Kamal in here was saying that NASA and AWS are providing some COGs. It's not going to be across the board, but yeah, this technology is really starting to penetrate a lot of things. Hey, thanks guys in the chat for more color commentary. Great. Our COGs is for genetics. Well, wonder if you could just use the same tech. It's still an image, right? Okay, so that is all I had for today's session. Back. Okay, everyone. So yeah, that's all I wanted to tell you guys about cloud optimized Geotiffs. I hope you learned something new. Please reach out to me if you're interested in going a little deeper or talking about how it could be applied to what you're doing. I would love to chat with you. And next week, we will do another cloud native format, only it's going to be cloud optimized point clouds. So it's essentially the exact same idea, only we are we're using photogrammetric and LiDAR point clouds. So same thing. So I look forward to it. So please hope to see you next week. So thank you guys.